Okay.
All right, so we're solving equations for a few problems.
Okay.
So first one, it's half, so 1/2, and then x plus 2 squared.
Like that?
Yeah,
Okay.
plus 3 equals 5.
All right. We want the last step to be this.
Okay.
So we got to get rid of everything else. We got to get rid of this half. We got to get rid of this 3. We got to get rid of this 2. And then we got to get rid of that 2. So let's take it one at a time.
Subtract 3.
Okay, so now we have this. Give me the next line. Tell me what you're doing and then give me the next line.
So how about multiply both sides by 2?
Okay, what's the next line? That's correct.
X plus 2 squared equals 4.
Okay.
And then square root both sides.
Give me the next line.
X plus 2 equals 2.
No. Remember, whenever plus or minus, always start your answer with those words when you are solving an equation by taking the square root of both sides. And it matters. We would lose a solution if you just put 2. So now what is x equal to?
So x is equal to 0 or it would be -2. Oh, 0 or -2.
No. In other words, here, what this means is that x plus 2 is equal to plus 2, or x plus 2 is equal to minus 2. That's what that means right there. Solve each one separately. What do you get?
You get 0.
Okay, and then this bottom one solve.
-4.
That's how you do that every single step. It was actually a good problem because we had to do virtually everything you have to do to solve an equation. We had to add, we had to subtract, we had to multiply, we had to square root, and then we had to subtract again.
All right. Absolute, so it has the absolute value signs. 3x plus 4. And then -7 equals 9.
First step.
Add 7.
Okay. Next step.
Subtract the 4.
No, absolute value has a very specific meaning. If I say the absolute value of x equals 7, then that means two things. That means either x equals 7 or x equals -7. So do that with every single absolute value expression. Take whatever's in the middle, whether it's x or 3x plus 4, and let it equal to 16, and then also let it equal to -16. So tell me what two things this can mean.
3 and -3.
Hold on, read the equations to me. There's two equations that come out of that.
So 3 times 3.
No,
Oh,
no,
no.
we're not substituting anything. We're solving
Oh.
an equation. In other words, whatever is in the parentheses is what you write, or whatever is in the absolute value.
Oh. 3x plus
Whatever it
4.
is. Yeah, whatever it is, no matter how complicated. If it's simple like x, then you just say x equals 7. But if it's more complicated, like 3x plus 4, then you say 3x plus 4 equals 16. Or what?
Or 3x plus negative 4 equals
No,
16.
never change what's inside the absolute value. Never change that.
Okay.
Only change what's on the other side.
So 3x plus 4 equals negative 16.
Now, solve each one. And the reason I wrote them horizontally is because we always have to solve them. And we're used to solving equations vertically. So that's why I wrote it horizontally, so that we can solve each one going down that way, and we'll come up with 2 solutions. And that's correct. You normally do have 2 solutions. So solve the one on the left.
It would be, so you'd subtract 4,
Okay.
and you'd get 3x equals 12, and then you'd divide both sides by 3 and get x equals 4.
There's one solution over here.
You'd subtract 4 again, and you'd get 3x equals negative 20. Divide both sides by 3, and you'd get x equals negative 20 over 3.
That's the answer you want. You don't want to turn that into a decimal or a proper fraction.
Okay.
That's a good answer right there. Okay. So the thing about absolute values is they're kind of like quadratics. You're almost always going to have 2 answers. But the way you do it is very definitely by using this system. Hold on. Trouble scrolling down. In other words, tell me this. Solve that.
So you'd make 2 equations. X squared minus 2x plus 10 equals 7, and x squared minus 2x plus 10 equals negative 7.
You got it. That's how you do it. And then you just solve each.
Yeah.
All right. What else you got?
Okay. 2x plus 1 equals, and then square root of 8x plus 4.
Okay. When you have a radical sign in an equation, you try to isolate the radical sign, which is already isolated. And then what are you going to do?
Set the other side equal to 0.
How do you? No, you're going to square both sides.
Okay.
In other words, if we're taking the square root and we square it, we'll end up with 8x plus 4.
Yeah.
I basically square that side, which means I got to square this side. Now, what do you get on the right?
Oh, just 8x plus 4.
What do you get on the left?
Do you have to do the FOIL equation?
Yes. In other words, what that means is 2x plus 1 times 2x plus 1.
So you would get 4x squared plus 2x plus 2x plus 2 or 1 plus 1.
1 times 1 is 1.
Yeah, sorry.
Okay, now what we're looking at is a quadratic. We have an x squared term, we got a bunch of x terms, and we got a constant. That's a quadratic. We're going to put everything on one side and try to factor it if we can. So let's put everything on the left side. And the reason I'm going to choose the left side, because the left side already has a positive coefficient for x squared. That's what you want. It's hard to factor a quadratic if you have a negative coefficient on your x squared term. So you want it to be positive. So I'm going to leave everything on the left. So everything on the right, move over to the left and simplify. I only have one of those. What's next?
Plus, I'm kind of confused on this part.
Okay, well, first of all, let's combine those.
Oh, so 4x.
Okay, now let's move the 8x that's on the other side over to the left. How many x's are you going to have?
Negative 4x.
See, you weren't confused.
And then,
Numbers.
Plus 3.
Always remember, when you're moving something that's being added or subtracted to the other side of the equation, just change its sign.
Okay.
So it's going to be plus 1 minus 4. In other words, I got to subtract 4 from both sides, right?
Yeah.
Well, that's plus 1 minus 4.
So it'd be negative 3.
And what's left on the right side?
0.
Okay, now we have it in the form of a quadratic that we can work with. Now, I don't know automatically that this thing will factor nicely. I'm going to trust that the teacher wouldn't give you one that wouldn't factor nicely. Can I do anything first? Can I take a greatest common factor out of that?
No.
Good. No, you can't. So let's try to factor it normally. What's the most likely way to split up the 4x squared?
2x.
2x and 2x. Doesn't have to be that. It could be 4x and 1x. But you're always going to, on these quadratics, which is a trial and error process, then we're always going to try the factors that are closest together first. If those don't work, we'll go back and we'll try 4 and 1. What are my signs? What's the second step in factoring?
Minus and positive.
And this time, that's the same as minus plus. As long as that coefficient is the same as that coefficient, plus minus is the same as minus plus. So I don't even have to write it that funny way that I do, where I put the plus and the minus and have to deal with both of them. Now, how many factors of 3 are there?
1.
So it's either 3 and 1 or vice versa. Now, what middle term does this give you? Do the double smiley faces, multiply the inside and the outside, add them together, that's your middle term. What's the inside?
6x.
I put the plus there just because I know I'm going to have to add it to another number, so let's make sure we put the plus there. What's the outside?
Negative 2x.
Add them together.
4x.
Plus 4x. Is that the correct middle term?
Yes.
No, it isn't. We're looking at minus. We're looking at minus 4x.
Yeah.
What does that mean? What's my answer? I got to switch my numbers. Instead of plus 3 and minus 1, it's got to be plus 1 and minus 3. I just switch them around. Now, notice the middle term is plus 2x. The outside is minus 6x. Add them together and you do get minus 4x. So the fact that we saw that the middle term was the correct number but wrong sign was useful. We knew we had it. So all we had to do is switch the number. Now, fully solve this. The goal is to solve this equation for x, correct?
Yeah.
What's the next step? I got my two factors. Here's what I got. I got 2x plus 1 times 2x minus 3 is all equal to 0. How do you solve that? What's the rule in algebra that says if I multiply two things together and it's equal to 0, what do each of those things have to be?
Um,
0. You cannot multiply two numbers together and get 0. There are
okay.
no two numbers that multiply together to get 0 unless one of them is 0. So that's the whole reason we factor. That's why they spend 2 solid years teaching you to factor, is because when you get a quadratic equal to 0, you have to separate it into two things multiplied together that are equal to 0. And that you get from factoring. Now I can say, well, that means 2x plus 1 equals 0, or 2x minus 3 equals 0.
Okay.
Solve each of those. One on the left. What's x going to be?
X equals -1.
Okay, let's do it one step at a time. What's the first step?
Subtract the 1.
Second step.
Then divide by 2.
So what's the answer?
-2.
Okay, first step gives you this, correct?
Yeah.
Now divide both sides by 2. What is x equal to?
-1/2.
Uh-huh. Yeah, don't say it with questions. That's as likely as answer as any. That's the
Okay.
answer. So be confident in it. Now do the same thing for the other one. First step,
Add 3.
last step.
So x equals 3/2.
Yeah. Lachlan, the biggest thing I could advise you on, just do everything one step at a time. You know how to do it. Where I see you get into trouble is when you try to do 2 steps at a time. In other words, when you try to go from there to there in one step, it does not work for you. Do it in 2 steps. If you have to do it in 2 steps, you do it in 2 steps. You get the right answer. That's what's important. Okay? Now, let's back up a little bit here, because this problem started out with a radical sign. And when you have a radical sign or an absolute value, you need to check both solutions. I kind of forgot to do this on this other one. So let's go back to this other one. In other words, the fact that you have an absolute value in an equation is very, very likely to cause an extraneous solution. One of these solutions might not be any good. So let's take the first one, x equals 4. Plug that in. Does that work?
Yes, it does.
Yeah, the absolute value of 16 is 16, minus 7 is 9. Now take the minus 20 thirds and plug that in. Does that work?
No.
Actually, it does. I get minus 20 plus 4, which is negative 16. And the absolute value of negative 16 is positive 16.
Okay, yeah.
16 minus 7 is 9. So both solutions work in the absolute value. Now let's go down and check both solutions in the square root one. That was one I made up to give you. Let's keep going until we see the square root problem. Did I not write it? Did this, I guess this did not start out as a square. Yes, it did. It started out as a square root. There it is.
Yeah.
Okay, hold on a second. What were my solutions? My solutions were x equal negative 1/2 and x equal 3/2, correct?
Yeah.
All right. This was our starting spot, right?
Yeah.
Okay. Plug that in and see if everything works. What's that equal to when x equals negative 1/2?
0.
Okay. What's this equal to when x equals negative 1/2?
0.
Okay, so that one works. Now let's plug in 3/2. What's this one over here when you plug in 3/2?
What would be?
What is 2 times 3/2 plus 1?
3.
No, you cross those out. Now you got 3 plus 1.
4. Yeah.
So 4 squared. So this thing is 16. Now plug in 3/2 into this side. Oh, excuse me. I didn't really, that's not 16. That is 4.
Oh, okay. Yeah.
I had squared on both sides there. But it's 4 that's going to be equal. And when I plug in 3/2, I get 12 plus 4, which is 16. Square root of 16 is 4. So
Yeah.
both of these solutions do work. But I'm just warning you that there are 3 kinds of equations where you have to really, really be careful about extraneous solutions. Okay? And here's what they involve. Absolute value, radical signs, or logarithms. If you have any of those 3, then you definitely want to check both answers. Because we haven't had one yet, but very frequently one of the 2 answers will not work. Remember what the rule says, that when you're multiplying 2 things together and it's equal to 0, they don't both have to be 0. One of them has to be 0. So it's entirely possible that the other answer is not a solution to the equation. Just as long as one of those things is 0, it satisfies the rules of math. Nothing says both of them have to be 0. It's just that's the way you solve it, and then you test each solution and see if it's right. All right, what else do we have, Walker?
Now we have algebraic. We have to solve the systems algebraically.
Okay.
So y equals parentheses x plus 4 squared, and then minus 4, and then y equals negative 3x minus 6.
There's 2 methods for solving these algebraically. What are they?
You can equal them to each other.
Which is substitution.
Yeah.
And the other method is elimination. This does not lend itself very well to elimination. Right offhand, I'm not going to be able to eliminate much. If I added the equations or subtracted the equations, that doesn't lend itself at all to elimination. But it lends itself very well to substitution, because that y is equal to that y. This is a system of equations. The x's are equal and the y's are equal. So if y is equal to y, well then I can do this. X plus 4, which is the top y, minus 4 has to be equal to the bottom y. Now we just have an equation to solve. First step.
Do you subtract the 3x and subtract the 6? Or add 3x, add 6?
I don't mind that. No, I like that. So when I add the 6, how many numbers? In other words, let's start with the 3x. When I move it over to the left side, what does it become?
Just its own number.
Plus 3x.
Yeah.
In other words, I just moved that to the left side. Now let's move the negative 6 over. What's the net result?
2 plus 2.
Plus 2. Okay, so now we got that. Now I cannot solve this by taking the square root of both sides, because these two started off on the other side, but I can't take the square root of both sides because then I'll end up with a square root sign over the x term. So how can I solve this? What's the only thing I can do? I don't know. I don't have any other way to proceed other than there's only one thing to do. When you run into a math problem and you don't know what to do, but you see something you can do, it's usually a good way to proceed forward.
You do FOIL?
Yep, do it. What do you get?
So x squared. And then 4x plus 4x. Plus 4x.
I got both 4x's in there.
Oh, okay. And then 6 plus 16.
Keep going.
And then plus 3x plus 2.
Okay. Gather all like terms, simplify.
So x squared plus 11x plus 18 equals 0.
Now factor that. Again, we have no way to solve that. But if I can make it the product of two things, then I can say each of those things must be 0.
Yeah.
So what is it the product of? Get you.
Yeah, so x and x. X plus
Don't do
9
it
and x plus 2.
Now do both signs as the next step. I want you to really get this process ingrained in your head as to how to factor. The way you factor, you split up the x's, that's step 1. Second step, determine both signs. That's step 2. Now, third step is factors of 18 that add, because of that, to the number 11. And you have correctly surmised that it's 9 and 2. I just didn't want you to do it ahead of yourself. The biggest problem people have with factoring is they try to solve that completely, and then they go try to solve that. That's not the way to factor. The way to factor is you split up the x's, you figure both signs, and then you do step 3. So what's my solutions?
So x equals -9 and x equals -2.
Yeah. And because this doesn't have any radical signs in it, it doesn't have any absolute value signs, doesn't have any logarithms, I don't have much doubt that this is going to work. I never at one point had to take the square root of both sides. I'd almost bet my life that both of these work. So I don't spend the time checking both of them. When you just have a regular looking polynomial and you factor it, both always work. It's only on the unusual looking equations where you really have to pay attention and check. All right, what else you got?
So it's another solving system algebraically.
Okay.
And it's y equals 2x squared plus 2x minus 13.
Stop for a moment. Whatever the second equation you give me is, what method am I going to use? Substitution or elimination?
Elimination.
No? Well, at least, I mean, you could, but the rule I use is if I have one of the two equations fully solved for one variable, I always use substitution.
Okay.
And regardless of what the second equation you give me is, I've got one equation that's fully solved for y. Now give me the second equation.
Y equals x squared plus 8x plus 3.
Now this one's going to be particularly easy because they gave us both equations fully solved for y. So now that y is equal to that y, so what's the next line?
So y equals
Y.
no.
We're substituting. If that y equals that y, then that equals that.
Oh, okay, yeah. 2x squared plus 2x minus 13 equals x squared plus 8x plus 3.
Now notice what happened. We took two equations and two variables, and now we only have one equation and one variable. We can always solve one equation and one variable. Almost always. What's the next step?
Now you do you get all onto the left side?
You got it.
So 3x squared?
Nope.
No?
No. How do you move the x squared that's on the right over?
Oh yeah. Sorry. X squared. And then minus 6x. And minus 16.
Okay. All equals 0. Very important part of that. Now let's factor that. And it's always worth trying it. Sometimes if that was a 15 instead of a 16, this wouldn't factor. But with it being 16, it does factor. Factor it.
So 2 x's.
Good. Second step.
A plus and a minus.
Third step.
So now it's going to be...
Verbalize the third step for me.
Well, you...
Factors of what that do what?
Factors of 6, which adds to 16.
Oh, you're close. It's factors of 16.
Okay, yeah.
Always factors of the constant, because this constant is produced by multiplying this number by this number, the L of FOIL. Okay? That's how we knew the signs had to be opposite, because whatever numbers I'm going to write in are going to multiply. The last step of FOIL is multiplying them together, and they have to produce a negative number. So now, the other thing is it's factors of 16 that don't add, but they subtract because of that negative sign. So the third step depends on the sign in front of the constant. The third step is factors of 16 that subtract to the number 6. What are they?
X plus 2, x minus 8.
Good. Well, the third step was finding the factors, 8 and 2. They subtract to the number 6. And there's a fourth step. Whenever this sign is a negative on the constant, there's a fourth step. You have to put the larger of the two factors with the sign of the middle term. Well, the sign of the middle term is minus, so my 8 has to go there, my 2 has to go there. If I check it, I got 2x minus 8x. That gives me minus 6x. I've done it correctly. Now, what are my solutions?
-2 and 8.
I think we'll check both of these. I might be wrong about polynomials never producing extraneous solutions. -2 and 8. So plug in -2 into equation 1 and tell me what you get for y. One term at a time. Figure out that term first.
16.
No? What's -2 squared? First of all, you do that term.
Oh, okay.
What's
-2 squared minus 4.
Nope. Minus times a minus is a plus.
Oh, okay, yeah. 4
Now times 2?
2, 8.
Okay, so that's 8. Now, plus, and the way you really should do this is this way. Do not try to do these in your head. Just do that. Now simplify it. What does that turn into?
-9.
Yeah. So the y coordinate that goes with the -2 is -9. In other words, that equation gives you -9 if you substitute -2. Now let's substitute -2 down into the second equation and see if it works. We'll see, make sure we still get -9. So what's squared?
Is 4.
Plus 8 times -2 plus 3. What is all of that?
Is 9. -9.
-9. So that solution works perfect.
Yep.
Now let's go back and plug in 8, our second solution, into the first equation. Let's figure out a y value.
Wait, what are we doing?
We're plugging
putting
we got two solutions on this problem. The first one was an x of -2, which gave us a y of -9.
Yeah.
That satisfies both of these equations. And the second solution was an x of 8. We haven't yet figured out what the y is. So let's plug it into the first equation and figure out what y we get when x is 8.
So 8 squared.
64 times 2 is 128.
Plus 2 times 8, which would be 16.
Minus 13, that's 131. So that's the y value that goes with an x of 8. Now let's make sure that we get 131 down there, and we'll know both of our answers and the x and y coordinate of both of our answers.
So 8 squared, 64, plus 8 times 8, which is 64 also, plus 3, So that's 128 plus 3 is 131.
Perfect. Both solutions work, and you do need to always figure out what y is. In other words, figuring out what x is not enough. Whenever you have a system of equations, when they say solve it, they mean give me an x and a y. So if there are two x's, there's two different y's also. All right, what else we got?
So now it's arithmetic with functions.
Okay.
So the equation is, well, like the equations we use for it is f multiplied by x. So
First of all, that's not f multiplied by x.
F parentheses
That
x.
is, the way you pronounce that is f of x.
Okay.
What it means, it does not mean f multiplied by x. It means we have a function and the variable is going to be x. So whatever we write on the other side of this equation is going to have x's in it. Not y's, not r's, not t's, x's. The beauty of this notation, as opposed to saying y, is when you write y, you don't say what kind of a function it is. You don't say it's a function of x or a function of t. We don't know until we see the function. But when I write f of x, I know the other side is going to have x's only. No y's, no t's, no r's. Only variable is going to be x. What's the right side?
And then 2x minus 5.
Okay.
The other equation is g of x equals 4x plus 13.
Okay. What do they want?
F plus g of x.
Okay. What is that going to be? Just add like parts.
So would it be 6x minus 8?
Uh-huh. 6x plus 8.
Yeah.
You're adding negative 5 to 13. Okay, what else they want?
And then f multiplied by g.
Foil them.
Okay.
You sure it's f multiplied by g and it's not f of g of x? There's
It's
something
f.
called fog. It looks kind of like this. F of g, like that. Which has a special meaning all on its own, if we get to that. Okay, so this is definitely f times g, okay?
Yeah.
So you got to multiply f of x times g of x.
So 8x squared 26x.
Need a sign.
Plus 26x.
Notice that if I left the plus sign out, that expression wouldn't make any sense. Sometimes you can leave a plus sign out, sometimes you can't. The 8 does not need a plus sign in front of it. It's the first term. So if I don't put a sign in front of the 8, it's assumed to be plus. But if I don't put a sign in front of 26, I got nothing. From here to the end, I got to have signs in front of every single term. What's the next term?
Minus 20x. And then minus 65.
Okay, let's simplify that. You can almost always combine those two middle terms. You can almost never find any more x squareds or any more numbers. But the two middle terms always combine. That's my double smiley faces. That's the inside and the outside. that produces our middle term. So we end up with 8x squared. What's the...
Plus 6x minus 65.
Yeah. And that's f times g of x. Or f of x times g of x, or f times g. All of them mean the same thing. What else do they want?
F plus f.
Okay.
Um,
Add f to itself.
so 4x, would it just be 4x?
You got to add both terms. In other words, I'm
Um,
adding 2x minus 5 plus 2x minus 5.
4x minus 10?
What else? In other words, these are real easy. Where they get hard is when they get into the f of g of x.
Okay.
Fog or goff, those kind. I don't know if
Yeah.
you're going to have any or not, but keep going to find out.
There's just one more, and it's g minus f.
Okay, so they're not getting into the composite functions yet. Okay, what's g minus x? Or g minus f?
2x, and then plus 8.
Okay, here's what we got. 13 minus a negative 5.
Oh, okay, plus 18.
Okay. Do not drop negative signs. It's the biggest mistake in math. People want to drop negative signs. I guess they don't like negative signs. I never met anybody like negative signs, but you still can't drop them. If you drop them, you're getting it wrong. No two ways about it. You cannot drop even one negative sign. When you come across a negative sign, just write it in. If you come across 2 in a row, write them in. If you come across 5 in a row, write all 5 of them in. When you get to calculus, you actually do come across 5 in a row, believe it or not. Calculus is full of subtraction. And if you're subtracting negative numbers, well, there's 2 in a row right there. Okay? So do not drop negative signs. All right, what else we got? We got 10 minutes. We got another kind of problem?
Yeah, we have solving an inequality.
Okay, good.
So 7x plus 13 is greater than or equal to 4x minus 11.
Okay. Go.
You make it equal to the equation?
No. So far, you can solve an inequality much like you solve an equation. There's only one time where it's significantly different that you have to be aware of. And this problem's not going to do it. So go ahead and solve it like an equation, only leave that sign the same at each step.
So subtract 4x and add 11.
Okay, so now I got 3x plus 24 is greater than or equal to 0. Now what? Isolate x. We want our final thing to say x is greater than or equal to some number.
Oh, so subtract 24 now?
So since I'm going to have to do that, it would have actually made more sense to just put that on the right side originally, right?
Yeah.
In other words, when you're gathering your variables and your numbers, if you're not looking at a quadratic, if you're just looking at a linear equation where you just have an x, you don't have an x squared, well then always put your variables on one side and your numbers on another. So this line really shouldn't have been that. It should have been 3x is greater than or equal to minus 24, right?
Yeah.
And that saves us a step. That's what I get if I go that route, but then I got to do another step to get here. Now what's x equal to, or greater than or equal to?
-8.
Yeah. And that's our answer. And we didn't have to do anything different than we would do if we were solving an equation. The rule is that if you have to multiply or divide both sides of the inequality by a negative number, then you have to switch the direction of the inequality. So if I had come up with this, minus 3x is greater than or equal to minus 24, solve that. Separate problem, totally different, but how would you solve this?
So would you just divide it by 3?
You got to divide by that entire coefficient, not just part of it. That coefficient is negative 3.
So x
So if I
is
divide by 3, I'm going to be left with a negative x. Well, that's no good. I want my answer to be x. So yeah, I got to divide by negative 3, both sides. And since I'm dividing by a negative number, what do I have to do with the inequality sign?
change it,
Okay,
like switch it.
the answer. So that's
X
definitely leaves x.
x is less than or equal to 8.
Correct. In other words, you have to actually still divide both sides by the negative number, and you have to switch the direction. And that is whenever you are dividing or multiplying, not adding or subtracting, but dividing or multiplying. Which we didn't have to do as long as you move the x's to the left. Had I chosen to start this problem by moving the 7x to the right, well then I'd have had a negative 3x over there, and I would have at some point had to divide by a negative number. So you try to leave your coefficients of the x term positive. Always makes it a little easier. In other words, when you're deciding which side to move stuff to, kind of like equations, you usually try to move the variable to the side of the equation that leaves it with a positive coefficient. Let's try one more, Lachlan. Then I have a 4:30 I'm going to have to go to, so well, we got time for one more.
2x squared minus 3 is less than 7x plus 1.
Unfortunately, this involves a lot. This is not an easy problem. We can go through it in 5 minutes. Why don't I show you how to do it, because I doubt that you're going to know how to do this. What I'm looking at is a quadratic, okay? The reason I know that is because I have an x squared, I have an x, and I have a number. Whenever you have all three of those, you got to get everything on one side. So I move everything to the left, and I can do it without dividing or subtracting a negative number. And I get this. Okay. Now you got to factor that. Let's try factoring it. So slightly harder than a normal factoring problem because it's got a coefficient other than 1 in front of the x squared. Whenever you have a coefficient that's not 1, it makes it kind of a second tier factoring problem in terms of difficulty. Split up the x's. Step
2x and x.
Figure out both sides. Step 2.
Plus and minus.
But in this case, it could be plus and minus, but it could also be minus and plus, which is different because the coefficient of my x term is different in both entities. So whenever the coefficient, that's a 2, that's a 1, then I got to allow for both plus minus and minus plus. Now, factors of 4, what are the two most likely factors we're going to try? First of all, let's talk about factors of 4. We got 4 and 1, and we got 2 and 2. What's the first one we should try?
4 and 1.
No, we actually should try 2 and 2. Remember the rule of thumb, that the factors that are closer together are more likely to be your right answer. So
Okay.
this is a trial and error process. I'm going to try all combinations of 2 and 2. If that doesn't work, I'm going to go back and try combinations of 4 and 1. Well, it's pretty easy to see that 2 and 2 doesn't work. Why?
Yeah.
Because that's plus 2x, that's minus 4x. Well, that doesn't get me anywhere near 7. And switching the 2's around will give me 2 times 2x, 2 times x, wouldn't do anything. So, in other words, plus 2 or minus 2 is not going to work. So I know it's not 2 and 2, it must be 4 and 1. Well, let's try that. Here's where we're at. 2x plus minus. Over here we have x minus plus. We're going to try 4 and 1. Now let's try 4 and 1, just randomly. I'm not even going to try to figure out the answer. Does this work? What middle term does this produce?
-4.
No, this answer right here that I've just tried, the only way we can tell whether it's correct or not is to figure out the middle term. If it's minus 7x, it's correct. If it isn't, it's not.
It's -3.
Okay, it's not minus 7x. And in fact, it's not 7. It's not
Yeah.
plus or minus 7. If I move the 4 down to the negative sign and move the 1 down to the positive sign, I get the same number, just the opposite sign. So moving the 4 down and the 1 down isn't going to work either. So let's try our only other option. We'll put the 1 there and the 4 there. Now what do we get as a middle term?
-3.
Come on, Lachlan, do your arithmetic correct.
Oh, we got
Minus 4 times 2x.
-8.
X. Now add those two together.
Equals -7x.
Perfect. That is our middle term. That's the answer. So the answer is 2x plus 1 times x minus 4. Now, had we gotten a plus 7x, then I would have known the answer is just to move the 1 down to the negative sign and the 4 down to the positive sign. That would produce the same number, opposite sign. So sometimes you have to do all 4 possibilities to see how you get the answer, but a lot of times you can get away with only doing 2 of them. You don't always have to try all 4 combinations.
Yeah.
Because either you produce the correct answer before you try all 4, or you produce the correct number. And once you produce the correct number, a 7, now I'm halfway there. I only have to it's either the correct sign with it, or if it's the opposite sign, I move these numbers down to the negative. Hold on 1 second. Hello? Yeah, this is David. Yeah, can you hold 1 second? I'm finishing up an appointment. Let me go ahead and sign off, and then I'll be right with you. Just hold, just hold for 10 seconds. Okay, Laughlin, I gotta go.
All right. Thank you.
You're welcome. Talk to you next time.
All right.